true, false. In number 1, subspace is also a vector space. Yeah, that's true. Smaller vector space inside bigger one. That's why the name subspace. That's true by definition. A vector space, a vector is any element of a vector space. Yeah, that's the name. Yeah. It could be a polynomial, but we can still call a vector because it's a member of a vector space. A vector space is also a subspace. That is also true. Okay, because a vector space is subspace of itself. Number 4, that's by definition again. R2 is a subspace of R3. R2 means we got like AB. All the members are written in this way. R3, ABC. Look, this AB is not like ABC. So it's false. In fact, R2 is not even a subset of R3 because these vectors do not belong to R3. So false. R2 is not a subset of R3. Number 5, the null space of A is the solution set of the equation AX equals 0. That's the bold fat, so this is a vector. That's true. I mean, this is how null space is defined. All the x's in domain that are mapped to 0 vector. So the collection of all x's in domain that are mapped to 0 vector, that's the null space. That's true. That's by definition. The null space of an m by n matrix is in Rm. So when we have a matrix mapping this, so m by n matrix, that means this is Rm. It works backward, okay? Rm, Rn. And the null space lies here, so it should be null space is in not R. This is false. Should be in Rn. Okay? Null space is here, column space is here. Column space is here, by the way. So this is false because null space is in Rn because the matrix is m by n. So m by n. Number 7, the column space of A is the range of the mapping x to Ax. Yeah, that's true. Okay, just mapping x to Ax. So these x's, whatever x's are mapped here, and that's the collection, that's the column space. That's true. If the equation Ax equals b, in fact this is vector, is consistent, then column A is Rm, everything. Like we got here Rm, Rn, and Ax, A is a matrix mapping this to this, so A is m by n. Ax equals b is consistent, then column of A is Rm. Okay, I mean column A means all x's that are mapped to this. That's the column space here. But this B could be outside anywhere. I mean, that's what they are saying. When that is consistent, that does not mean column of A is whole thing. Column A is whole thing. No, that's false. Because this B is coming from outside, and it does not say for all B. If it says for all B here, for all B, then this should be the case. But it just says 1, so it's not true. It's false then.